Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous video, we had seen one topic. Just let me first of all open out that particular place, and yeah, here it was. So we had seen regarding the comparison or comparing of the two independent population means with the known population standard deviations, right? This was what we had discussed today with the topic as well. We had seen the comparing of two independent population proportion, but yeah, that is right now we are just not going to consider that particular topic. So in today's video, we are going to see out a question with this particular topic, right? Let me just write out here as question. Just 1 second. So let me just write out here as question, fine. So we are going to solve out this particular question in today's video, which is totally related to the formulas which we had already seen into that topic which I was discussing, and that is comparing two independent population means with the known population standard deviations. Right, so let's get started. So now what does my question says to me? So my question says independent groups, population standard deviations known, the mean lasting time of two competing floor waxes is to be compared. 20 floors are randomly assigned to test each wax. Both populations have a normal distribution. The following table is the result. What is the question that you need to find? The question is that does the data indicate that wax 1 is more effective than wax 2? Take at least test at a 5% level of significance, right? Okay, so this is a particular question which we need to solve out here. In this question, I am mentioned what are things that I am given. Let me take out a highlighter and highlight all that things. Right here. So I'm just given the mean lasting time of two competing floor waxes to be compared. 20 floors are randomly assigned. The randomly assigned value is 20 floors, right? To test each wax. Both populations have a normal distribution. The following table is the result. This is the main table which we'll be seeing wax 1 and 2. Then we had sample mean, that is the number of months floor wax last. So for wax 1 it is 3 and for wax 2 it is 2.9. And the population standard deviation, so the population standard deviation for wax 1 is 0.33 and for the wax number 2 is 0.36. Right, so now we just need to find out the things here. So let me just take out a pen and let me just go on to the color and figure out a pen here, and then let's get started with the writing part. So okay, let's find out the solution for this particular question which we are given out. So we need to find out that does the data indicate that wax 1 is more effective than wax 2, and second one is test at a 5% level of significance. Fine. So let me come down here. Fine, let's start writing out the solution. So in my solution it says this is a test of two independent groups of independent groups, right? So this is a test of two independent groups, and okay, independent groups comma two population means I would just write that two population means it is population standard deviation. Its population is standard deviation, that ST is standard deviation, okay? Okay, not that is S dot D standard deviation, okay? Population standard deviation, fine. And yeah, so this is basically the things which we are already know. Standard deviation, no. Okay, so this is a test of two independent groups. Two population means population standard deviation is known. Okay, what about the random variable? So random variable, that is x1 bar minus x2 bar is equal to difference in the mean number of months the competing floor, okay, let me remove out this competing because we are not able to understand that what I have written out here, even I am not able. So right, months mean the number of months the competing floor waxes last. Okay, so this is the idea that the random variable, that is x1 bar minus x2 bar, is equal to the difference in the mean number of months the competing floor waxes last. Okay. Now what is this H naught? H, that is H0. What is this actually? So it is mu1 less than equal to mu2. Okay. What about HA? That is alternative hypothesis. Above one was null and down one is alternative hypothesis. So that one is mu1 greater than mu2, right? These are the conditions which we were having in this. Now come down. Write out the next thing, that the words. Now if you have read out the question carefully, then you must be getting out this particular sentence. The word is more effective. Is more effective says that wax 1 lasts longer than wax 2, right? When we just talk about that something is more effective, so in that case you are just like indirectly saying that this particular thing lasts longer than this particular thing, right? So here we have taken the example for the wax. So when this term came that which wax is more effective, so in that case it actually means that like wax 1 lasts longer than the wax 2. Okay, fine. On the average, we are not just completely satisfying because we need to find out this particular thing, but yeah, onto the average we can just put out this particular thing, that on the average, full stop. After that, longer longer is a greater sign, greater symbol. Longer is a greater symbol and goes to HA. That is basically my alternate hypothesis. So it means that this is a right. This is a right. Let me just come down. So it means that this is a right-tailed test. Okay, it means that it is a right-tailed test. Fine. Now, what about the distribution for this particular test which we are given? So here comes the distribution. Okay, so we already know about the population standard deviation. We already know this particular thing, right? So basically the distribution is normal. In the case when we are familiar with the population standard deviation, so we say that this particular distribution is normal, right? So let's put out the formula. That is x1 bar minus x2 bar. Let me come down. Approximately equal to n into the bracket. Okay, now just figure out what was the formula for that standard normal distribution. U1 minus U2, yeah, right? So here just given 0. Nothing, I'm just I'm having here, right? Putting out the under root. We were having sigma 1 squared upon n1. Go above to the question, find out what is the sigma 1. What is sigma 1? Sigma 1 is my population standard deviation. So 1 is 0.33 and second is 0.36. What about the n? So n we are having total which is 20 floors. So that same I would be taking out, right? Now just let me come down here, put on the things. So for the first one we were having 0.33, right? Square upon n1 we were having 20 plus, and then we were having 0.36, right? Whole square divided again by 20. Fine. So since mu1 is less than equal to mu2, then mu1 minus mu2, then mu1, okay, just let me come down. Since mu1 is less than equal to mu2, then mu1 minus mu2 is less than equal to 0. And the mean for the normal distribution is 0. Okay, the mean for the normal distribution is 0. Now when we are just going to calculate out the p-value, so that p-value is finally gonna come as 0.1799. See the formula for comparing for finding out the p-value. Let me come down. So yeah, this was okay. So just find out this accordingly. And even the formula for the p-values, we had already discussed that into the previous videos, right? So that you can just took out from there. After that, if we talk about making out the graph for this particular thing, so I could click on draw, and take out the x and the y. No, I do not want x and y axis. I simply want one single line. So I could just make that line like this here. And okay, where's that color gone? So just one second, draw and then color here, and here I could just make a normal distribution curve, right? This is how that normal distribution curve is made, right? Here I could just put on some points, and in between it would be 0. This is 0.1, and it is x1 bar minus x2 bar. This particular, what is that? That is my p value. P, okay, just let me remove out this P, and here goes the value. So what is that P value which we had find it out? 0.1799, right? We had just put on this thing. So, and what we had concluded from H naught, that is my from null hypothesis, mu1 minus mu2 is less than equal to 0, right? This we had concluded. And taking out a color from here and putting out and filling out this particular portion, right? Because this is the one which we had actually find it out, this particular portion. Right, so that I have completed out here. So from this, what I could actually conclude, let me now just come down. I could put out here that x1 bar minus x2 bar, that was we were having 3 minus 2.9, that is equal to 0.1. Just have a look, we were having these two values. This is the 3 and this is 2.9. Okay. So x1 bar minus x2 bar, that is 3 minus 2.9, that is equal to 0. Now we are gonna compare out the values actually. Compare alpha and the p value. Okay. So alpha we are having 0.05, right? What about the p value? So p value I was having 0.1799. So in that case I could say that alpha is less than the p value, right? How to find out alpha? We had already discussed this thing. So now here we can actually make out a decision that since alpha is less than p value, so do not reject H naught, right? This was only the condition which satisfied that if alpha is less than the p value, then in that case we do not reject out the H naught. So that is same actually which is applying out here. What about the conclusion for the 5% level of significance? So we can say that at the 5% level of significance from the data, from sample data which we are given, so there is not any sufficient evidence to conclude that the mean time wax for 1 lasts longer than the mean time wax lasts for 2, for the second wax last. So we are here basically we do not have any sufficient evidence to conclude out this particular thing that the mean time wax 1 last is longer than the mean time wax 2 last. Right? Hope you just got the idea that how to solve out this particular question. That does this indicate that the wax 1 is more effective than wax 2? Test at a 5% level of significance. So when it is mentioned 5% level of significance, so in that same case, I had taken the value for alpha is equal to 0.05. So this is the value which just came from 5%. It is only the 5%. Okay, make sure to remember out that thing. Right? Hope you just got out the idea that how to solve the questions like this. So this is all for this video. Till then, thank you and take care.